So you have to evaluate the integral I is equals to, it is integral of 1 by root of 7 minus 6x minus x square times of dx. We need to evaluate this one. So to evaluate this one, once again, either you have to go for a plus b whole square formula, which is a square plus 2ab plus b square, or you can use a minus b whole square, which is nothing but a square minus 2ab plus b square. So out of these two, any one we have to express. So let us just try to simplify this one. It is 1 by, it is root of. What I'll try to do is 7, this x square is having a negative sign. So it's better we take that negative sign common outside, because both are having negative sign common. You can take negative sign common from here. So 7 as it is minus. So what I'm doing over here, I'm writing this 6x, and because minus is gone outside, you're left out with x square times of this dx as it is. So now let me use a standard formula. It is integral of 1 by, it is root of 7 as it is minus. First I'll write x square, which will give us this a square value, plus 2ab plus 2. 2 is what over here? 2 into a. A value is x only. 2x into b. So what should be the value of b such that I get 6? So 2 3s are 6 will be getting. So you got a square plus 2ab. 2 and a was known, only b have guessed it. This is just guessing, just by seeing 6. To get 6, what has to be multiplied? 3 has to be multiplied. So 2ab is over, plus b square you have to get. So b over here is this 3 only. So what I'm doing, I'm taking minus sign outside. First I'm writing this x square as it is, no change, which will be acting as your a square. Next I have to write plus 2ab plus 2. A value over here is x only first, into b. So what should be b? You have to guess b. What has to be multiplied to get this 6x? 2 is already there. 2 times of 3 will give you 6x. So 2ab is over. Then how to write b square? B is 3 over here. So b square will give you 3 square. But this 3 square is not there in the previous step. This is the additional step that you have written. Therefore, you need to subtract that one. Add and subtract that 3 square, so that it will not change this original value. So close the bracket now. Times of dx as it is. Now if I try to group it, this grouping a square plus 2ab plus b square, a square plus 2ab plus b square will give us a plus b whole square. So let us use that one. So I'll be getting this value to be equals to, it is integral of 1 by, it is under root 7 minus, this is in the form of a plus b whole square. A value is x, a plus b value is 3, a plus b whole square. And this minus 3 square 9 will be as it is, times of dx. Or further, let us try to simplify, remove the bracket and simplify. It is integral of 1 by under root 7 minus, I'll multiply inside, I'll be getting x plus 3 whole square. Again, minus you multiply inside, minus of minus will become plus 9 times of dx. Or further, if you try to simplify this one, this will give us integral of 1 by root of. So 7 plus 9 will give us 16 minus x plus 3 whole square times of dx. Now you can use the substitution method. Put the value of x plus 3 to be equals to t. Now let us try to differentiate this one. So dx plus the constant 3 derivative will be 0 time is equals to dt. Or if you just ignore that 0, dx will be equals to dt. Hence we get I is equals to integral of 1 by root of 16 can be written as 4 square minus x plus 3 is t, we'll be getting t square times of dx. Dx is dt. So now you can use this formula. You know this formula, I is equals to, it is integral of dx by root of a square minus of x square, right? Integral of dx by root of a square minus of x square. The formula is sine inverse of x by a plus the constants, right? I've already shown you this formula, dx by root of a square minus x square is sine inverse of x by A. Now if you try to compare with this one, I is equals to, it is sine inverse of x value. X value will be t by A. A value is what? A value is 4. T by 4 plus the constant c. But what is the value of t in this case? T is x plus 3. Therefore, you can write it is sine inverse of x plus 3 divided by 4 plus the constant c. So that will be the required solution.